In this video, we're going to look at F equals MA, and this is probably the most difficult but most common question that comes up on this topic, and it's when two masses are connected by a string. So let's talk about how to go about doing this. I've labeled an important bit of information here, and I'd recommend you use that for all questions. So particles A and B of mass 2 kg and mkg are connected by a light inextensible string. Okay, so whenever there's an object, whether it's a string or a tow bar connecting two other objects, there's always tension acting up the rope of that object, and they always approach each other, the tensions. It says initially A is 3 meters above the ground. So straight away, what that should sort of tell you is that at some point you're probably going to have to use CVAT equations, otherwise it wouldn't really mention height in an F equals ma question. The string is released from rest. Again, that points to the initial velocity being 0, so you're probably going to have to use CVAT. And the fact that it's also giving you the time taken for A to hit the ground tells you, again, that you're going to have to use CVAT. Now, that also tells you the direction of acceleration, the fact that A will be traveling downwards. In that case, particle B has to be traveling upwards, otherwise A can't travel downwards. They're connected. So we've labeled the directions of acceleration. Let's now label all the forces acting on the particles. We've already labeled the tensions, however, there's also vertical forces acting downwards. That force is weight, and it's always equal to the mass, which is 2, multiplied by the acceleration due to gravity, g. We can now, for particle B, we're not really given the mass, so we're going to write it in terms of m. We're going to write mg. Part A says, show the acceleration of A as it descends to 0.96 meters per second squared. Now, a little trick on when you have to use F equals ma. Whenever it's a very high mark question, that always tells you that you're going to have to probably use two different F equals ma equations and combine them somehow. Part A, because it's given you so many other variables, is sort of pointing towards the fact that you have to use CVAT equations for particle A. Like I mentioned before, we're given, so let's write out the CVAT equations. I'll actually lay it out like this, you don't have to, but just bear in mind there's always 3 known variables and 1 unknown variable. In this case, we know that it's going to descend 3 meters. We know that it's initially starting from rest, so u is 0. We know its acceleration is, actually, we don't know its acceleration, that's what we want to find. We don't know the speed when it hits the ground, or velocity when it hits the ground, sorry. We do know the time taken for it to hit the ground, though, is 2.5 seconds. What equation links s, u, a, and t? It's s equals ut plus half at squared. So I'm just going to write that out and then substitute into that equation. So we have s is 3 is equal to u times t, which is 0 times 2.5, so we don't even need to include it. A half times a, which we're trying to find, multiplied by t squared, which is 2.5 all squared. From there, we just rearrange for a, so you can double both sides to get rid of the half on the left-hand side. So 2 times 3 equals, actually, after doing that, you can just divide both sides by 2.5 squared, which actually is 6.25. And that will give you the acceleration, which is equal to 25 over 21. Oh, sorry. 0.96, my bad. Meters per second squared. So that's part A done. I'm just going to erase it so we have a space for part B and part C, whilst you guys can still see the question. Okay, moving on to part B, that's where we use F equals ma on both particles A and B. Now that we know the acceleration is 0.96, it's going to help us form the F equals ma equations. It might be worth changing the thickness of the pen, so I'll just do that very quickly. 0.96, and that's in this direction too. Sorry, I have OCD. Let me just write that out one more time. You can skip ahead if you'd like. So A equals 0.96. Okay, let's form it for particle A first. Now, a very common mistake students make is misunderstanding what F actually is. F always stands for the resultant force. Now, that's the force in the direction of motion, take away the force opposing the motion. For particle A, the force in the direction of motion is the weight of 2g because it's traveling downwards. So we take the downward force. The force opposing the motion of particle A is the force upwards, which is tension. And then we can make that equal to the mass of A, which is 2 multiplied by the acceleration that we've already found of 0.96 in part A. 2 times 0.96, that's just 1.92, so let's replace that with 1.92. Okay, we can solve that for t, and let's do that because I'm sure it'll be useful at some stage. So add t to both sides, and then take away 1.9. I wouldn't advise you do it like this in an exam, by the way. I'm just rearranging like this because I want to save time for you guys. So that's an equation that determines t. I wouldn't round it yet because it might lead to rounding errors in the middle of the question. Now let's form F equals ma for particle B using the same idea. Again, F is the force in the direction of motion of particle B. So because B is moving upwards, the force upwards is tension. And we take away from that the force opposing the motion, which is the weight of particle B. That's mg. And that's equal to the mass of particle B, which we don't yet know, multiplied by the acceleration of particle B, which is 0.96. So we can say that's 0.96 m. We can now go about finding m because we know an equation for t. We can substitute that into particle B. We can say that 2g minus 1.92 minus mg, all I did was replace t with 2g minus 1.92, is all equal to 0.96 m. To make m the subject, let's first move all the terms with m to one side of the equation by adding mg to both sides. What we can then do is factor out m from the right hand side, so it's m lots of 0.96 plus g is equal to everything that was on the left hand side. Is equal to 2g minus 1.92, and then we can divide both sides by that bracket, so we can get m is equal to, okay, I'm going to be lazy one last time, everything that was on the left hand side divided by 0.96 plus g, and then that would equal 1.64 on your calculator. I know because I've done it beforehand, not because I'm a genius. Moving on to part C, state how you've used this information to that the string is inextensible. Well, what this means is if the string did extend, then that would affect the tension that's experienced on both sides of the string. Like this one might be larger than this one. But the fact that we assume that the tension is the same throughout the whole experiment is how we've assumed that the string is inextensible. So we've used the same tension for particle A and B. That's enough to get you the mark. So let's write used for A and B. Thanks for watching the video. Be sure to leave a like if it helped, and yeah, I think I made a few more videos on F equals MA, so be sure to keep a lookout for those, unless they're already in the playlist in the description. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.